All right, there we go. Well, welcome everybody once again to Astronomy Daily Live. This is Astronomy Daily Live for the 13th of January, 2019. Wow, so we're already about 2 weeks into the new year, and these date things are kind of arbitrary anyway. So I don't pay much attention to dates, but it is nice to note the passage of time, and kind of pay attention to when it feels as though it's going really, really fast and when it's going really, really slow. And I gotta say, I usually experience pretty fast time as a close, and greatly cherish when things are sort of moving a little slower, because I just it seems like I can get a lot more done when things are going slower. Of course, that's probably more or less a subjective thing. I don't think that time actually slows down or speeds up, but wow, sometimes it sure feels that way. So yeah, we'll hope everybody's doing well out there. Just a quick update with the OBS session last night. I did cancel it and kept checking things outside. The humidity was actually probably pretty good, but I went out a couple times and I looked up, and yeah, there were clouds. There were definitely some high clouds that were blocking most of the faint stars. I could see a lot of the brighter stars, maybe down to third magnitude or so. But yeah, there seemed to be some kind of layer up there. Definitely called it on clouds. But this time of year, in this location, southern Arizona, southeastern Arizona, that's pretty typical weather, right? We get a little bit of rain. It's almost but that will soon be gone. We're moving into mid-January now, and most likely by February, definitely by March, it is going to be clear. So yeah, just have to keep track of those kinds of things, and keep going with the plan. And in fact, and I'll get into this a little bit. Maybe I probably should actually. My plans I look like they're going to change a little bit in terms of how I'm going to characterize this telescope system back here. So I'll get into that momentarily, but I wanted to definitely welcome on the panel Bobby with the headphones.
Hey, what's up, everybody? Very good on the weekend.
Oh yeah, that's right. It's a weekend too, isn't it? Yeah. In fact, tomorrow, tomorrow and every Sunday is the free Music from the Hearts of Space show. So if you go to HOS.com, and I think you have to, actually sign in as a member or whatever it's called. It's free. It's free, to sign up. You just have to, put your email or something in there. And
for me, I can always get it like any day throughout the week and stuff, because I usually got that subscription.
Yeah, and that's another cool thing is that they offer these different kinds of subscriptions that sort of span span a few different services and things.
Yeah,
So
the
so
basic will give you the this week's show for every day throughout the whole week. The I think the standard can give you like not just this week, but you get like all of these episodes, and the full service gives you the on demand episodes of Horse Space this week, and then you get some ambient music.
very cool. Yeah, yeah. I actually subscribe to um, um, the the whole shebang there for at least a couple years, and that was really really nice. Because you can go in anytime you want and listen to anything you want. But for those who
Now, Cosmic, we was
Mhm.
looking at the orange yesterday and stuff like that.
Yeah.
If if at any time some if they have to go to a paid subscription, you want me to like help you out and stuff?
I appreciate that. I will definitely consider that. Yes. Yeah. Yeah. But obviously, let's see how that goes. And see what the terms are. See what the parameters are there. I mean,
Yeah, because password sharing, it's they're really cracking down on lots of services and stuff.
sure, sure. Yeah, everybody wants a little bit of this. That's moderately understandable. The AAS is I believe it's a private organization. So, they can pretty much do whatever they want. But oftentimes, there are workarounds and many many other ways. So yeah, well, greatly appreciated, Bobby. I will definitely, if that comes up, I will definitely keep that in mind, or you can remind me too. And yeah, yeah, maybe we can work something out there. It sort of depends, on costs and all that. But for now, the research notes of the American Astronomical Society are free, and I hope that it stays that way. And what's also free is every Sunday, the Music from the Hearts of Space weekly show. So I think they're on Pacific time in the United States. So uh, they're
And
free show. Go ahead.
yeah, like if they use Pacific time, then yeah, it would definitely be like 2 o'clock Central here and stuff.
Yeah, yeah. So yeah, but I think their weekly show is free from midnight to midnight on Sunday Pacific
Now, out of my
time.
curiosity, you ever been to a Soma FM?
I've heard of Soma. I'm sure that I have been over there for sure. But wow, it's probably been a while. I haven't actually. I haven't heard that name in quite a while. So
Yeah, I
um,
think usually every Sunday, one of the Soma FM stations called Drone Zone usually has some lengthy, long form ambient music. They usually go for about like an hour and stuff.
sweet, sweet, yeah.
That's
You know,
usually every Sunday.
yeah, cool, cool, cool. Yeah, I like a little bit of drone. Sometimes it's a little boring, right? A little bit. Um, but even with the ambient sound, the quintessential ambient sound, right, is like Brian Eno's Music for Airports, right? That
Yeah.
that
I also love group salad too. Sometimes I just want to do some chill, just want to chill out and stuff. I just go ahead and put on some group salad.
Yeah. Well, for me, for sure, when I want to work, programming or doing some kind of research or something, um, I will definitely put some nice space music or something here, and that really allows at least this brain to uh, um, sort of relax, right? And just sort of not necessarily focus, but just sort of relax. Don't have a lot of distractions or anything. And the music really helps with that, for sure. So yeah, very very cool. Anyway,
You
yeah.
like listening to like new age music and stuff like that?
Um, the new age music is a little, uh, yeah, that's a little. I mean, I like most kinds of music anyway, but the new age is a little, probably a little out of my zone. Um, uh, um, and there's a lot of it now too. So without being more specific, um, yeah, I really haven't been listening to a lot of that. Usually what I'll go for is either space music, ambient, or classical. Right, I really like all the classical stuff. Um, Once in a while, getting in the mood, I'll listen to some rock and roll, some old rock and roll, um, from 60s, 70s, 80s. Some of the 90s rock and roll is okay. This current thing, with hip hop stuff, I'm not. I mean, there are some interesting things, but I'm not really too keen on it. It's and maybe it's just because I'm turning into an old guy or something. But um, I mean, being a musician, right? I um, um, ooh, sorry, baby. Um, I've got the ability to sort of hear things in a different way, right? I mean, I can pick out um, the individual sounds
Yeah,
from
I guess as you
songs.
as you're getting older, you might want to listen to the songs that is more essentially around the younger when you was like young and stuff like that.
Well, those are the songs that we sort of connect with. But I mean, I don't. I I I really I don't. I mean, I've certainly got that kind of bias too, but I like to think that I am sort of open-minded, to all kinds of things. I try to be, at least, and so I listen to this modern stuff, and like I say, some of it's kind of interesting, but a lot of it just I don't hear any musicianship, right? I hear a lot of wailing voices, and not a lot of actual musicianship. And I think a lot of that has to do with the digital tools that we have now, to create sound and to create music, and it's just it's it's new. Well, and I mean it's not exactly new, not anymore at least, but uh, yeah, I'm just not too keen on it. But I definitely try to listen to it from time to time to see if there's anything interesting. The really great thing is that if you can find it, a lot of sort of the underground music, right, is still really great, really, really great.
Do
There's
you
some.
like music that has that copyright, or do you like to listen to music that has that Creative Commons license?
I don't really look at those kinds of things at all. So I mean, you know, if I listen to something and I like it, it's because of the sound, not because it has some kind of legal thing. It's so yeah, I don't really pay much attention to those kinds of things. I mean, it'd be nice, if everything was sort of in the Creative Commons um, area, but I can also understand why somebody wouldn't want to do that, at least for a while, right? I mean, it's your creation.
Kind of like
And
crazy that usually like let's say like the I watched one called The Internet's Own Boy, and that was about Aaron Swartz and stuff that died about a few years back. He was like anti Sopa Peppa. He was like anything that could be against the internet freedom.
hmm, yeah, well, to each his own, for sure. I think that is extremely important. So yeah, if that uh, um, if that's what's you know he was into, very, very cool, very, very cool. All right, well, cheers. I've got the HOH here, the hydrogen hydroxide again. So cheers to that. I'm gonna look in the chat really, really quick, see what's going on over there. ERRT Radio, nice to see you in the chat. Hope everything's well over there in the cold white north. I guess not so incredibly north, but definitely north of me. So yeah, so hope
How about
everything's
you like
going
to be in the green, the deep south green?
well. Yeah, there's a lot of green stuff, and there's a lot of wet stuff over your area, and I can't handle any of that. That's yeah, I don't know what to do with all that. So so yeah, no, I
I
am.
actually had someone that was on the shortwave show that was actually was shoveling and stuff. I told him to come to Louisiana where you don't have to shovel a day at all.
I have shoveled so much snow that I've just used up all of that, right? It's sort of like the same thing I say about being bored, right? I've I've been being a kid. I was oftentimes so intensely bored that I think I just used up all of my boredom, and I haven't been bored in 30 years because I think I just used it all up. Yeah, I don't even know what that's like anymore. Can't can't even imagine being bored. I do remember being bored though. But yeah, I can't imagine it now.
Yeah.
Just crazy, crazy, crazy. All right, well, cool. Yeah, so my photometry project has sort of taken a turn um, when I realized actually on this live stream that this effect called atmospheric extinction uh, is actually a thing for wideband photometry. So I'm measuring the brightnesses of a set of stars with this scope in order to characterize it, in order to see how
How is
how good
it
it works.
true if like the K index when you look at solar conditions, if it goes if it goes like up to 10, you're just pretty much are cooked, right?
I think a K index. I think the highest K index is actually 9, right? Um, so yeah, I think a K index of 9 is pretty well, and of 10, I don't even know if that exists. Um, I think that would be pretty exciting. I don't know if that's ever happened recently. I know, that we can get into 4s and 5s, right?
Oh yeah, for definitely sure when there's like a big solar wind and stuff.
Yeah.
Yeah,
So,
but like a M class or an S class comes around, you're pretty much screwed.
yeah, well, that sort of also depends on the direction, right? If there's an X class flare sort of on, one of the sides of the sun, it's usually going to blow out that way or that way. But if that same flare is sort of, facing Earth,
Is it
then
true
yeah.
that the next solar cycle will somewhere be around like late 2019 or early 2020?
Um, well, I think we're in a minimum right now, and those cycle every 22 years. So the maximum isn't going to be again for like 10 or 11 years. And I think right now, we're sort of in in the minimum part, and maybe we're starting to come out of that a little bit. We'll have to keep an eye on the sun and find out. Yeah. I mean, we've really only been paying attention to the sun for, I mean, in sort of a careful way, maybe 200 years, maybe, right? Um, really careful observations, maybe the past 50 years or, maybe a little bit more than that. Um, so that to me is just way too short of a time to allow us to get any idea about what the sun is doing, right? We really don't know. And the only thing that we can do, right, is observe and take that data, feed it into our models, and those models, uh, you know, like I say, have all kinds of variables, right? That you can move around and stuff, and you know, we can create models that will closely match the data that we have. And then we look at the variables and we say, okay, every 22 years, we reach a minimum. And but I just I don't think that we've really been looking at it long enough to really have a good idea as to what the sun is up to. Um, and who's to say that we're even looking at it, sort of the right way, right? We've got all kinds of instrumentation now, that is looking at the sun all the time, right? We have spacecraft. Um, we can actually look at um, sunquakes, right? Actual like acoustic vibrations in the sun, and actually do seismology that way. So we're getting pretty clever when it comes to making observations and better understanding what the sun is doing. But do we really understand what the sun is doing? Probably not. Probably not. So, even though we may think that we do, probably not. Now, what are you going to do? Do you have any idea? You're just standing here. All right. All right. Well, I think you need to settle. There we go. Happiness is having a kitty on the lap. So, absolutely. Absolutely. So, all right. Well, cool. So, yeah. So, um, the atmospheric extinction is definitely a thing. Even doing broadband photometry, like what I'm doing with my scope, no filters, no anything at all, and but it turns out that that actually is a thing. So and there's a wavelength dependence there too, right? So as a blue star rises in the sky, it'll that star will actually brighten, right? Um, but that blue star will actually brighten faster than a red star would, right? So it turns out that I have to take that kind of thing into account, and because I have to take that kind of thing to account, uh, my hope and my plan to be able to directly compare my brightness measurements to the brightness measurements of Gaia are sort of tanked. Um, what I'm going to have to do is I'm going to have to um, uh, make some new measurements in order to determine what the transformation is between my system and Gaia, because of course Gaia is a spacecraft, right? It's out in space. There's no atmosphere, so there's no extinction. So they don't suffer the same kinds of problems um, that ground-based observatories do. Uh, and I thought that I was going to get away with that because I was doing broadband and I was doing differential photometry. I was just looking at the differences between the brightnesses of stars. But if there's extinction and if there's a wavelength dependence there, then looking at the brightness of a blue star compared to the brightness of a red star, well, that is going to change as those two stars move in the sky, depending on where they are in the sky. And so I have to take that all into account now, which means to account and properly compare my measurements to Gaia's measurements, I'm going to have to figure out how to take either one of those and sort of transform them, right? So yeah, that's where that is. And so what I'm going to have to do is I'm going to have to actually make some measurements of these things that are called standard stars, right? These are stars in the sky, and there's lots of them, with very, very well-defined brightnesses, right? These are stars that aren't variable stars. Their colors are well known, and their brightnesses are well known, and so I'm going to be able to observe those. Measure the brightnesses of those myself, and I'm going to know that okay, my measurement says some kind of number, and that number means that it's this particular stellar magnitude and this particular color. Once I know that, then I will be able to transform between the two systems. And what that means is I'm going to have to correct my photometric measurements just a little bit. Some kind of number, and those kinds of numbers usually aren't linear either, right? They usually have some pretty high order terms. So yeah, it's something that I was hoping to avoid, but I'm not going to be able to avoid it. It's really, really a bummer. The good news is that I found out about this, and the software I was actually working on it all day today, but the software got now is working really, really well. I am seeing differences in different colored stars. So the blue stars are getting brighter faster than the red stars are, and I can actually measure that change and see that, and that's kind of nice because knowing the colors of stars really can um, open up some really, really interesting doors in terms of research and stuff. Hey there, Tom. Nice to see you in the chat. Cheers. So that's where that all is. I'm going to have to change my program a little bit and start observing some standard stars. Shouldn't really have to do too much of that. I think after I get a couple, maybe 2 or 3 or 4, I'm going to have a pretty good handle on how I'm going to have to transform all of these, to go between my system and Gaia. So the more stars I can sample, of course, the better. But I think after 2 or 3 or 4, I'm probably going to have a pretty good handle on that. So that kind of thing I can do in just a few hours, right? I mean, a few hours, I can definitely have all that done in terms of data collection. Then, of course, I'm going to have to reduce the data and do the analysis and do the measurements, and actually come up with these transformation factors. But I don't see any reason why I can't do that. I mean, I've done this before, so it's not as if this is completely new. It's just a different system, and like I said, I wasn't planning on it. It's like So, but yeah, you got to do what you got to do. But what I'm seeing is that once I get this down, I think my accuracy right now I'm seeing an accuracy of about 40 or 50 millimagnitudes, right? So when I measure the brightness of a star and then I compare it to the brightness of Gaia, I'm off by 0.04, 0.05, 0.03 magnitudes pretty consistently. But what I'm seeing in taking into account extinction is that accuracy is actually going to drop by at least a factor of 2, if not even more. Sometimes maybe even a factor of 10. So and so what that means is once I get into the realm of sub 10 millimagnitude accuracies, there's a lot of really, really interesting things that can be done there, and that is really, really great for science, right? Actually doing scientific research, you want your measurements to be as accurate as they can possibly be, and if this system can do 10 millimagnitudes or better, then that is very, very, very awesome, very awesome. So things like observing the transits of the exoplanets becomes a real possibility, and that's just one thing. But that sort of gives you an idea as to what can be done. So to be able to see a planet, passing in front of a star, that's pretty cool. That's pretty cool. So, and there's a lot of discovery of these things is sort of one major step, but a really important aspect to this is all the follow-up and the months and the years of just making measurements and looking and seeing what's going on. Are these periods regular? Are they changing? All kinds of things. And the only way to do that is to observe these things over the long term. So yeah, that's kind of a fun thing. But yeah, with that kind of accuracy, that'll be really nice. So yeah, I'm just having to change the program a little bit. I've got to observe a few standard stars to get this transformation thing done. And I hope once that's done, I can sort of move forward with some actual science projects and continue to offer this system to people who want it. So very cool. All right, well, cheers to photometry. Oh, yeah, I think tomorrow I'm going to take a break from all this stuff and probably just do some music. Maybe I'll do some composition. I really haven't been playing on the keyboard over there or my guitars or anything. So
no music gigs.
No, there haven't been any of those either. That those sort of come and go. Yeah, I don't think that we've got anything. Don't think that we've got anything planned right now, not as far as I know. So yeah, there isn't anything going on in terms of gigs or anything at the moment, but that will undoubtedly change for sure. But yeah, I think maybe tomorrow I'm just going to dive into some music a little bit and sort of take a break from battling the computer and the software, because yeah, I was doing that all day today, and after a while, one's brain just turns to mush. So that's sort of the state of my brain at this point is just a mushy mass. All right, well, cool. I was one of the other things that I haven't been doing recently is going over to archive.org and seeing what the latest and greatest astronomical papers are. So since I haven't done that in a while, I sort of thought, well, let's do that on the live stream here for a little while. So let me see. Let me pull up archive.org. So archive.org is this great repository of mainly scientific papers. Share my screen here. There we go, to infinity. But this covers lots and lots of things, right? Lots of areas of physics, right? Of course, including astronomy, but all kinds of other physics too, right? You name it, almost, it's here. But they also have mathematics and computer science and biology, finance, stats, electrical engineering, econ. So yeah, just whatever you're kind of interested in, this is a great place to keep in touch with sort of the latest and greatest in research and new ideas and all that. These new papers, they come out every single weekday, right? So not on the weekends, but every single weekday around 1 hour UTC. Sometimes it's a little bit sooner than that. Sometimes it's a little bit later than that. I'm not exactly sure, why it seems to vary a little bit, but usually around, like 1 hour UTC every weekday, a new list comes out. Now, I got to admit, I don't really look at any of these other ones. I probably should. So I'm not quite sure how many, new biology papers come out. But in terms of astronomy, usually we get somewhere between 40 and 100 new papers every single day, right? So that's a lot, right? It's really, really, really amazing how much work is actually going on, sort of behind the scenes. And, to get to a point where you actually see a paper, usually, requires months or years of research, to collect the data and to analyze it, and to write the paper itself, can take weeks or months, and then they have to submit it, and it has to go through peer review, and that bounces back and forth a couple of times, and all the editing, make sure everything's spelled right, make sure all the pictures and the tables and the graphs are all in the right places, and reference correctly, make sure all the references are correct, right? So it's a huge process, each of these papers, right? And so the fact that there are 40 or 50 or 60 or 100 of these every single day, it just blows my mind, right? Because I've written papers, right? I know what's involved in doing that, and it is no small feat, right? So definitely hats off to all the authors here and co-authors, because it's a monumental task, to have to write these things. But that's what scientists like to do, right? Scientists love they're just absolutely dying to tell everybody about their work and the results and everything, right? And that's part of the scientific process as well, because once you publish your results, then others can check it, right? Either by repeating experiments, or looking through the paper, see if there's any errors, all that kind of stuff. And that is most definitely the process of science. Great stuff. So I'm going to go to the recent list here, and let's just go. Let's go back to last Monday, because, like I said, I really haven't been checking on these as often as I normally do. Sometimes I jump off the boat a little bit, and just don't get around to it. So what I like to do is I like to just go through these titles and see if anything sort of grabs my interest. So I just sort of, quickly scan all the words and see if there's anything, that just sort of pops out. And most definitely, if you see anything, let me know on the chat, or Bobby, if you see anything here, just say the word, because I'm not the only one that can decide these things. We can all
I don't find anything interesting yet.
yeah, I mean, a lot of these papers, most of these papers go way over my head, right? Where I'm not really even understanding, what the titles are saying, much less, the papers themselves. But, once in a while, it's like, huh, what is that? So that's sort of what I like to look for first, is just look at the title and, see if there's anything um, moderately interesting, like, spectroscopy of dwarf stars around the North Celestial Pole. It's kind of cool. I don't exactly know why they would choose, the North Celestial Pole. Why is that such a big deal? I don't know. That's sort of an arbitrary thing. So I don't know. Let's dive into this one a little bit. Let's look at the abstract, right? So Tess and Plato will perform an analysis of bright stars in large fields of the celestial sphere, searching for extraterrestrial planets. Seismic observations will search for exoplanet hosting stars. Blah, 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 blah. Right. Characterization is important, right? However, atmospheric parameters. Okay. Well, this is actually exactly the problem that I'm trying to deal with too, right? And so I guess atmospheric parameters just aren't in great abundance when it comes to brown dwarf stars. Okay, so they are looking at the spectra of these stars in the northernmost field of the celestial sphere, with a radius of 20 degrees from almost due north, right? So not quite sure. Okay, so I guess the reason why they chose that is because it's the center of one of the fields that Plato is looking at. Now, I've never heard of Plato. I've
Me
heard of
neither.
Yeah, I've heard of Tess. I've never heard of Plato. So I'm kind of, I'll bet that in the introduction to this paper, they might talk about Plato a little bit. But if they don't, yeah, maybe we should sort of investigate that a little bit. I'm always up for, new space missions. And Tess, of course, is doing amazing work already. But let's see.
I'll think about for the next live stream. We'll probably see if Tess got some more information and stuff.
Sure. I know that Tess is planning a data release in the next couple of weeks, I think.
Okay.
Yeah. We can look for that pretty easily here. I think we can go over to the Tess spacecraft test mission, and I think that they posted the dates here. Data release products. Let's see if they say cameras, images, discoveries. Let's see. Let's go over to here. Dun, 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 dun. Prime mission. Oh, okay. Not seeing. Let's see if there's any.
I don't think you got anything about data releases yet. What do you think?
Yeah, I saw something about it when I was looking the other day, but I don't remember where I saw it. So that's that's sort of the difficulty. Recent news, science image. per science observation sector. Yeah, it's somewhere. I'm not exactly sure where, though. So
Maybe do a Google search again and find out, and maybe post the link or something.
yeah, maybe, yeah. Anyway, as far as I know, they're supposed to be doing data release for sector 3 and 4 in the next few days, as far as I recall. In fact, what we can do, all right, let's be a little stubborn here. Data release schedule. Here we go.
Yeah, I was a little bit stubborn too and stuff. And trying to get my gallium working again.
Yes, you have to. If you want something, you got to, you got to work for it a little bit. Okay, this just came right back to here. Let's see if MAST says anything at all about that. No. Oh, okay. This just went right to the to here. Let's go to is Tess even here? Yeah, Tess is here. Let's see if this says anything. Data release notes. Science data products. Yeah, this isn't going to tell us anything. Well, let's alerts, release notes. Here we go. Test team, creation of the alerts, how to navigate the alerts, download data. Wow, I'm not seeing anything.
Oh man.
Let's look. Oh, didn't I do that one already? I think I did. I meant to click on that next one. This one. Let's see. So I'm actually kind of curious about Plato too. I want to see if we can maybe find out a little bit about that. I think I'm gonna switch gears and go over and see if we can find anything about Plato. Let's look at the actual paper and see if they say anything about Plato. Because I mean, is this a survey? Is this a spectroscopy? You know, is it in space? Is it on the ground? Is it, I don't know. So let's see if the paper itself, usually, the introductions give a nice, overview of various things. But let's see. So here they mention it again. Here they mention it again. Possible Plato fields. Target selection. Yeah, they're not saying much about Plato. So.
Ron, you have a question about scopes or what?
The question?
I think Ron has, yeah.
Okay. Yeah, this is definitely a place to ask questions if you have it. I will not claim to have any kind of answers whatsoever, but if I've heard anything or know anything, I can definitely pass it on. So here we go. Plato is the planetary transits and oscillations of stars. Third medium class mission of ESA's cosmic.
How would you characterize the 1 to 2 millimeter refractor, or 20 millimeter shouldn't?
How would I characterize them? I'm not exactly sure what you mean by that. Because a Schmidt, of course, is just a particular kind of reflector. those are pretty much the same size. So you can sort of expect the same light gathering ability. Schmidt telescopes tend to be a little faster in terms of focal length. So they may have slightly wider field of view. But yeah, not quite sure what you mean by characterize, because that's sort of a very specific term. Okay, so just in terms of what do I think of those kinds of things? Well, I can definitely say that OPT is a very great place. So and 102 for 349. Yeah. What kind of mount is it? Is it like an equatorial mount? Is it computer controlled? Is it manual? Because I mean, with 102 millimeters for 349, you're more or less paying for the mount, right? The telescope itself, the optical tube assembly, as they call it, the OTA, um, really isn't all that expensive. But those kinds of things, pay attention to the mount. But I would say that's a pretty reasonable size, right? And a pretty reasonable price for that size. Yeah, for sure. But yeah, I think for that price, you're not gonna you may not have like any computer control over the mount or anything like that. Not quite sure. Not quite sure. If you've got something specific in mind, like a particular name, we can definitely go over and take a look at it. We could do it right here, right now, if you want.
Yeah.
Okay, so Plato is going to be looking for exoplanets as well.
And I think he just started with that mission as well.
It looks like that is true. See, from the 4th of October, they're just constructing it now. So definitely not anything that is happening at the moment. But let's go over and just sort of take a quick look here. We could probably get into the whole thing here. Here's a mission summary. Okay, so here's some basic information, optical wavelengths. Okay, here we go. So launch date 2026. Just started their development phase. So okay, yeah, they're
how they know that in that paper that Plato is just getting started?
Well, my guess is that they've put out some science goals. They probably have a relatively good idea in terms of where they want to look, and how they want to look. Yeah, see, and so yeah, this paper is just sort of using that basic information and saying, well, hey, hold on a second, we don't know much about these stars that you're going to be looking at. So let's look at these stars first, and there they are. There they all are. They've actually worked out exactly what they're looking at, and cool. So yeah, they took spectra of these stars with this spectrograph called an Echelle spectrograph. It's an extremely high resolution spectrograph. The this background I have here, right? This thing, this is a spectrum of the sun taken within a shell, a spectrograph, and it's very, very high resolution, um, meaning that these wavelengths are spread out over a lot of area. In fact, in this case, right, they had to sort of fold it all up. And that's what they have to do, with these kinds of spectra, because they're so big. They have to fold them all up like this. So yeah. So this is the kind of spectra that they've apparently taken of all of these stars, right? To properly characterize them, and their light going through the atmosphere. And they're looking at some really, really bright stars, right? 8th magnitude and brighter. So just the brightest. Oh, I got a doggy alarm. So here's some examples. So see, this is a profile plot, right? So what they've done, and I'm going to go back to my spectrum here, is they've sort of drawn a line sort of through this spectrum, right? And see where it gets dark here, like dark here and here and here and here, right? That's what these dips are, right? So this would be a dark area, and then a lighter area, and a dark area, and a dark, right? So typically, that's called like a profile plot, just showing the actual depth of these lines and actually the shapes of these lines. And the shapes and depths of these spectral lines actually tell you a lot about what's going on. And of course, each of these lines, each of these dips correspond to some element inside of the star that is actually absorbing light. And that's why it gets dark, right? Because the light is actually being absorbed by that population of atoms. You can also have emission lines where these would go up, right? But in this case, not seeing a lot of emission, just seeing a lot of absorption, which means that there's some kind of light source behind, and then that light is going through this stuff, and some of that light is being absorbed, right? And so obviously you don't see it. If it's being absorbed by the atoms, you're not going to see it. And that's what creates the dark lines, is that light is actually going through stuff and being absorbed. And this is a very, very, very narrow band, right? From here to here is 30 angstroms, which is 3 nanometers. So that's a very, very, very narrow band. But you can see, a lot of detail, a lot of resolution in here. And that's sort of the characteristic of these kind of spectrometers, is that, they're extremely high resolution. So you can see lots and lots and lots of detail. And that's exactly what you want to see, right? Because the more detail you can see, the better you'll sort of have an understanding of what's going on with all these guys. So yeah, they're just looking at a bunch of stars. I'm not exactly sure. Okay, so yeah, these are actually examples of the solar spectra, right? Spectrum of the sun. So of course, they're all going to look about the same because it's the same object. Come on, you're going to move up or move down, one or the other. Oh, this thing's frozen. Dun, dun, dun. Try over here. With graphics like this, that brings the system to its knees often. There we go. It's trying. It's trying. I'm going to try to get off this page. Come on, you can do it. I know you can. We just have to root for it. Come on, you can do it. I'm scrolling down.
I said, Mom, and do that whip cracking sound.
Yeah. Here we go. There we go. Okay, very good. We're slowly moving down. It looks like maybe the next page has some graphics too. So, yeah. Sometimes this poor machine of mine just has a hissy fit with all this stuff. Maybe I'm gonna try to kill one of the windows here. That might help a little bit. I don't know. What's this one? I don't know. Let's see. I'm gonna keep moving down here. See if we can. Because this is like a 14-page paper. So I'm gonna try to keep moving down here. Trying. Just got to be patient. That's you know, good scientists are very, very patient. Sometimes I'm a good scientist, sometimes I'm not. Kinematics, that's just, you know, all the things that are going on inside of these objects and around these objects. Wow, this is really, I don't know why this is being so incredibly stubborn. But maybe I'm a little bit more stubborn. I don't know. Dun, dun, dun. Looks like a pretty good sample, though. Oh, we moved past things pretty rapidly there. That's all right. I'm not going to worry too much about it. Wow. I don't know why this thing is being so clunky. Lots of graphics, I guess. Doesn't know what to do with it all. Well, come on. You can do it. I know you can. So yeah, you know, spectra can tell us so many things that, you know, just looking at the brightness of a star just can't. If you can spread that light out and actually see, you know, various components inside of the spectra, you can learn all kinds of fantastic things about, you know, what's going on with these objects, you know, what they're made of, how they're moving, what their temperatures are, you know, how intrinsically bright they are. Just all kinds of amazing things. Even things like, you know, magnetic field strengths and gravitational strengths. Yeah, just lots and lots of cool stuff. But yeah, wow, this thing is really clunking along here, almost to a point where it's like, well, okay, but let's stick with it here for a second, because it's kind of hard to follow if it's, you know, I'm scrolling down and then all of a sudden it just jumps really, really fast a couple of pages, and it's like, wow, you know, we missed all of that.
You usually don't have that problem and stuff unless you're doing like a heck of a lot of work.
Yeah, I don't know. It's you know, you can blame the sun, right? You know, the sun is probably doing something.
Yeah, it's sometimes you gotta watch out that resource controller and stuff. Sometimes you do have to reboot.
Yeah. I'm not exactly sure why it's being so slow and clunky here. I can actually, let me kill Twitter. I can probably kill this. I think this was a paper. Yeah, I was looking at this before, but I think I've saved this. So that's probably why, because it's looking at all these PDF files. So I'm going to kill that.
Don't try to kill that. Yeah. Sometimes because my phone could be so stubborn,
Uh-huh.
I could accidentally close my scripture reading tab.
Oh, that's no good. Yeah, well, this thing is being incredibly stubborn. But it looks like, you know, they're just trying to characterize these stars because nobody has. And in order for, you know, spacecraft like TESS and Plato, that you know, they need to know about these stars as much as they can possibly know, right? Because they are, you know, trying to find something new, um, and you know, if they find something not expected, um, they want to be able to go, you know, to the literature here and say, ah, okay, we're seeing that also. So, you know, that's not a planet, right? Um, and so, you know, they don't have to waste their time, you know, spending a lot of effort and brain power and person power working on all, you know, chasing, you know, something that you know is already well known. So it's nice that these guys are doing this. So okay, well, yeah, it sort of looks these histograms are sometimes really cool to sort of look at because you get an idea of sort of, you know, the distribution of objects. I'm going to try to move back up if I can here, because this is showing temperatures and gravities and what's called metallicity, right? The ratio between the amount of iron and um, hydrogen that they see in the spectra. So yeah, you know, you sort of look at the peaks here, right? And it looks like, at least in this sample, the majority of the stars, what, are around, I don't know, 6,100 degrees Kelvin or so. So yeah, you know, our sun is about, I think it's about 5,000 Kelvin, 5,000 or 5,500. So somewhere around here. So these stars are, you know, statistically at least, in the majority of them, are a little bit warmer than the sun. Um, I think log G, as I said, I think that's a measure of the gravity, and uh, so yeah, you know, that's around what, 4.2-ish or 4.3-ish at the peak. And then, wow, you know, there's sort of a wide distribution of metallicity here. That's kind of interesting. Okay, let's keep moving down here. I'm noticing what time it is too, so maybe it's about time maybe to wrap up a little bit, especially if this thing is going to continue to be a little on the stubborn side, which it looks like it's wanting to be. But I really like looking at the diagrams and, you know, the pictures and stuff. Really gives a good idea sometimes. Let's see. Not seeing anything too exciting there. Still trying to move down. Got a kitty back on the lap. Here, you know, here are these guys trying to fit data to a straight line, just like what we were doing the other day. Kind of flew by that, of course. So this paper is the first data release of the oh, no, I don't know where I am. I think I scrolled back up.
Now, when it comes to fitting data in a straight line, what's the possibility it might like kind of like bend and stuff or curve?
Well, there's a good possibility of that, right? You know, what is normally done is, you know, you consider that, right? And so, you know, it's just a different function. You know, the sort of the methodology there is sort of the same, but when you get into, you know, what are called nonlinear functions, functions that aren't lines, you know, the mathematics gets a lot more complicated really fast. So, yeah, that is very often done. Yeah.
Like your own
They're
paper dough.
Yeah, it sort of looks like. But yeah, look, you know, they looked at 213 dwarf stars that are brighter than magnitude 8, 20 degrees, um, 20 degrees max from the north celestial pole, which sort of matches where, you know, Tess and Plato is going to be looking. They noticed that 140 of them are slowly rotating. That's kind of cool, and you can get that, you know, from the spectra. The other 73 stars. Let me try to move back up here slowly. So we're either fast rotators or double line boundaries or binaries. Okay, interesting. Okay, so yeah, you know, they were either I'm noticing, you know, that they spun really fast, or there was some kind of binary system, which is not surprising either. So the kinematic thin disk, I'm not quite sure what that is. That probably has something to do with where they're located in the galaxy, you know, sort of aligned with the galactic plane. That's my guess. And yeah, you know, trying to see how they're moving, looking, as I said, you know, at the metallicity. And yeah, you know, I think according to astronomers, anything that isn't hydrogen and helium is considered a metal. Yeah, you know, that's kind of a sort of a pretty crude terminology there, but yeah, you know, that kind of terminology has just sort of stuck. So yeah, I mean, you know, it's really amazing, right? You know, to realize that, you know, after all these years, right, these really bright stars, only 30% of them have been, you know, sort of looked at in this way. It's really amazing. Yeah, you know, it's 2019 and we haven't, you know, really examined these all that much. Kind of amazing. Kind of amazing. Anyway, all right. Well, now that this thing is working so well, I think it's about time to get out of here. So, excellent. I'm going to look back in the chat really quick. Okay, cool. We're good in the chat. All right. Well, I think it's time to get out of here for now. So thanks everybody for coming in. Have a great evening, a great day. Hope the skies are clear where you are. You know, go out and take a look. You know, even if you're in a bright location, you can usually see, you know, the moon, some of the planets. Actually, a lot of the planets right now are you know, relatively near the sun. If you get up early in the morning and look east, you can see Venus really bright and pretty high up, and Jupiter is sort of a little bit lower in the east. So you can see those guys. Mars is up in the evenings. Saturn is pretty close to the sun, so kind of hard to see at the moment. Uranus and Neptune are actually up also, but they're pretty faint, right? You need a telescope to see those guys. I think at some point we should definitely take a look at Neptune and Uranus through that scope. You know, do some kind of live stream. It's not going to be anything interesting, but you know, you'll definitely be able to see it. You know, as a round circle. Probably won't be able to see any kind of details, but you never know. You never know. So, you know, planetary observation is something that I definitely want to get into. There's some interesting things that can be done with that. So yeah, for absolute sure. All right. Well, take care, everybody. I will see you in a little less than one dizzying spin of this little planet. All right. Take care, and I will see you. I will see you later. Bye.